Hello everyone, myself Uma S, working as Assistant Professor, Department of ACE. In ACLIC lab, our today's experiment is amplitude modulation. So before starting with the experiment, let us know what is modulation, what is the need for modulation, what is amplitude modulation. So what is modulation? So modulation is basically it's a process where we vary the characteristics of a carrier signal such as amplitude, frequency and phase in accordance with the instantaneous values of the modulating signal. So this is the definition of the modulation. So the modulation is required because when we want to transfer a signal from one point to the destination point or another point, if we want to transfer a signal from one point to another point without any interruption, interference or affecting the signal, we need this modulation process. So in order to transfer a signal, the modulating signal is transmitted along with the carrier signal. So always the modulating signal frequency is lesser than the carrier signal. Carrier signal is a higher frequency signal. So our today's experiment is amplitude modulation. In amplitude modulation is defined as a process where we vary the amplitude of the carrier signal in accordance with the instantaneous values of the modulating signal. So let us see the circuit. So this is the module for amplitude modulation and the demodulation circuit. Here the very first thing is we must have two signals here. One is the carrier signal and the other one is the modulating signal. So the modulating signal must have a higher amplitude and the lesser frequency compared to the carrier signal. The carrier signal must have a higher frequency and the lesser amplitude compared to modulating signal. So in this module we have, this is the kit for a generation of the carrier signal. So here we are using the IC XR2206 for a carrier wave generation, and we are using an external signal generator for the modulating signal. And this part is the modulator circuit where we generate the modulated output of the amplitude modulation signal, and this is the demodulator part. And this modulator part, this is the transistor modulation technique we are using here, and this is the demodulator technique that we are using is a envelope detector. The main parts of the envelope detector is the diode and the low pass filter. Here diode acts as a main element for the envelope detection. So when the diode is on, the capacitor charges to its peak, and when the applied voltage is less than the capacitor voltage, it starts discharging. Here one of the important parameter to be considered in this envelope detector is that the capacitor must not neither charge quickly nor discharge slowly. So the circuit is designed in such a way that capacitor must not charge quickly nor discharge slowly. So this is about the kit. So let us turn on the components. So in this experiment, the carrier signal frequency is built in. We are not setting the carrier signal frequency since we are using a XR2206 IC. The frequency is built in range of about 100 kHz. And this for a modulating signal, we are using the external signal generator. Here I have set the frequency to 1 kHz and the amplitude is set to 5 volts. So in this experiment, I am connecting an external signal generator for the modulating signal. So from the external signal generator, I am connecting a wire to the AF input here. Here AF input denotes the modulating signal, and this is the ground point which is a common ground for the circuit. And then, so this is the knob to vary the amplitude, and this is the knob to vary the frequency. So since the frequency is fixed to 1 kHz, and this is the RF input. So say this is the carrier signal that we are getting from the XR2206 IC. From here it is connected to the RF input, and then this is our modulation kit module. So this output is connected to the CRO probe. So this is the output waveform what we are getting for the amplitude modulated wave. So if I vary this time per division knob, you can see here this is our input signal, the modulating signal, and this is the output signal, you can see here. And here there are three conditions to be met. One is the modulation index. So modulation index, there are three cases. The modulation index is equal to 100%, less than 100% and the greater than 100%. When the modulation is equal to 100%, we will get a waveform like this. So this is modulation index is equal to 100% means it means that it is a proper modulation. We are getting the proper modulation output. If we vary the amplitude knob of a signal generator, the waveform is varied. I am varying the knob of the amplitude modulator. So we can see the waveform is changed now. This is a condition for modulation index that is less than 100%. So this type of modulation we call it as under modulation, and the waveform we call it as under modulated wave. Once again, if I vary this amplitude, you can see the amplitude is varied. So this type of modulation is for over modulation. So this waveform we call it as a over modulated wave. This is for modulation index greater than 1. So in this over modulation there will be a phase reversal. You can see here there is a twisted signal that denotes the phase reversal waveform. So this is our amplitude modulated wave. So let us see the demodulated wave. In order to check the demodulated signal, this modulation block, the output signal must be connected to the demodulated input. So this modulated output is connected to the input of the demodulation kit, and the output of this demodulated wire, I am connecting this to CRO probe. So the yellow waveform denotes our input signal and the blue waveform denotes the output signal, that is the demodulated waveform. Though there may be the variation in the amplitude values, but the frequency of the input signal and the output signal must match. So this is our demodulated input. We can say that demodulation means it is getting back the original signal. So we can see the frequency values also. It's approximately the same. Approximately it's of about 1 kilohertz. So this is all about the experiment, the amplitude modulated wave and the demodulated signal. For this experiment, the expected viva questions like you must know the definition of the modulation, what is amplitude modulation, what is modulation index, the three cases of the modulation index, like what happens to the waveform when the modulation index is equal to 1, what happens to the waveform when the modulation index is less than 1 and when the modulation index is greater than 1, and the applications of the amplitude modulation. So these are some of the viva questions we must be prepared for. Thank you.